We have an interesting topic before we adjourn for tea. The speaker is Natarajan. He is well known to all the audience in Chennai. The topic is application of robotic in manufacturing industries. Mr. Natarajan, as I said, he is well known. He did his bachelor's in mechanical and master's in robotics, auto-guided vehicle path planning in the University of Toledo, Ohio, USA. He has been a certified ASME GTDP technologist in the past by undergoing the ASME certification examination. He was a research assistant in the University of Toledo and Ford Motor Company, USA for 5 years. His expertise are in the area of geometric dimensioning and tolerancing, dimensional management, design for quality, finite element analysis, design failure modes and effects analysis, value analysis and value engineering, design for cost, product design and development. His specific interest in plastics is he worked on instrument panel for Ford Mustang when he was at Ford. In India, he is right now a consultant to the Rane Group, TVS Group, Thermax, Shanti Gears, Precall, Texmo Industries, Roots Industries. The list goes on and on. I invite Mr. Natarajan to take the stage.
You're able to hear me even without the microphone, right? This is an interesting topic. When IPI asked me to present on this topic, I said it's a passion, it's not a topic. 1985, studying at CIT Coimbatore, the project that was given by Dr. Prabhakar, who eventually became the principal of the college, was there is a Department of Science and Technology grant for 65,000 rupees. Your previous batch has already spent a fortune on that. You don't have much money. The project was a failure. Can you do it? I said, what project is it? A 5 degree of freedom manipulator, a robot. I said, okay, we'll sit and do it. So 20 hours a week, 8 months, the robot was developed and it got a prize for the undergraduate projects in the list. And then it was controlled by an 8085 microprocessor. IBM PC-80 was not yet on the horizon when we did this. IBM PC-80 was not yet on the horizon when we did this, and the programming, everything was on the floppy. Remember, much water has flown after that. Today I am here in front of you to talk about application of robotics in the manufacturing industry. The word robotics sends a lot of different emotions to a lot of different people. Human beings always want to emulate the Brahma. They want to produce an equivalent of the Brahma. Another man they want to produce, to go and do their work while they laze around. That's called robotics, right? Huh? That's not what it is. So, at home you have a washing machine, right? It does the work for you. Still you have a housemaid who takes the clothes and puts it on the clothesline. Has she lost her job? It was value addition, value upscaling, right? So the common theme that people have is that robotics will replace people. No. Heavens no. Next question I ask you, I am making a case for robotics in your own industry. Not because I am speaking this subject or it's passionate to me, but because it's the name or the order of the day. The next question I ask you is, you have Alexa at home, right? It listens to your voice and sings the song that you want, turns on, turns off the light. Is it listening to you? It's doing work for you. Yes? That's a robot sitting there in your place. Okay, now come to your office. You have a worker whom you are giving 25,000 rupees per month salary. 12 months, 3 lakhs, plus other benefits, all those things. Then subsequently, the next year, he is going to demand at least minimum 10% raise, right? To beat the inflation. Yes or no? And then 10% on top of that? Huh? For the same work? You're going to pay more? Huh? Ah. So in other words, every year the operator is going to cost you more. The product cost is going to go up. You like it, you don't like it. It doesn't happen. That's wishful thinking. It's going to happen. So now you increase the value of the operator in your organization by upskilling him, by taking him away from the mundane jobs, which can be done using flexible programming and flexible automation. That's exactly where intelligence comes into picture. Decision making by humans and decision making by automated devices which take the decision so that the centrality of the specification limit sits there all the time. Best quality gets delivered consistently by the same operator but with an aid. So to 23 slides between U and T, it's what it is. Second slide we are on. Huh? So what you see on the right is a robot. Are you able to recognize that? It's a robot. Don't look at always the conventional manipulators with the 6 degrees of freedom. You know what it does? The moment you have, it's for the real estate market, folks. The moment you take this and put it on a level floor, it will go and put the plan of the level from your drawing on that floor for the rest of the people to do the real estate construction. Guess who is manufacturing this? Who is supplying this? Guess, take a guess. You will be surprised. I hope the name is there. It's there. It's not visible. It's HP. How many of us know this product? You go to the skyscrapers in all the cities, the Vishwakarmas of the West, you will see this product. In the high rises, in China, in so many different places. It's being used for meticulous planning and execution. What you see is what you get. Again, a robot. So why robotics? Step-by-step execution, options for the plastic industry, emerging technologies, cost versus benefit, and summary. Let's go. Why robotics? Cost savings, not by taking off the operator. Definitely not. Productivity improvement, absolutely. Multitasking is possible. Human beings are always unitary tasking, one task at a time, except women. Agreed? Let's agree. Men cannot multitask. Agreed? Don't try to replace her in the kitchen with a robot. Okay, quality enhancement and consistency in quality. It's not one-time achievement of quality. It's consistent 24/7, even if you are not there. Imagine going on a call to a customer, the customer changes the specification, you send it on your WhatsApp or on an app, it goes back to the robot, it does the changes, sends you the part. 2 days later, when you are still there at the customer place, with nothing else involved, you are able to see your cameras inside your house when you are traveling, right? Why can't you do this? Huh? Today's customer is impatient. He does not know what he wants. His requirements are changing all the time. Use this as a slave to get it done. So the flexibility, the adaptability, the labor intensiveness is taken away. The harmful environment is taken care of. Repeatability and reproducibility are assured. What more do you want in plastics? I still remember 1987, Hindustan Motors. I was going for an interview as a graduate engineer trainee. One Mr. Ravi, who was the vice president at that point in time in Tiruvallur, he was interviewing me and he said, "What is your final year project?" robotics. Oh, you want to remove all the people? I said, my interview is gone. My job is gone. You don't get many jobs in those days, do you? Huh? 87. I said, all the harmful, I saw a welding on your line. I don't want an operator to do that welding. He's going to lose his eyesight. He's going to lose his health. I was very bold. He turned around and said, I don't agree. Well, the operator will tell it 30 years down the line, not you and I. He smiled at me. I got the job. He was testing me, you know. So this is the kind of things that we have been exposed to. When I was working at Toledo, we were taking the developist robots, those robots, and we were using it to paint the Isuzu trucks. Normal painting was 6 to 7 minutes. This was doing it in 70 seconds with path planning. So high-level programming, kinematics, inverse kinematics, forward kinematics, so many things we have to do. Offline programming, then dynamic programming online. So many things are there. So the application is you can use it to handle very large parts which operators cannot handle themselves. Then in medical and healthcare, absolutely, it's a no-brainer. You better use it. Because today's robots are coming in surgeries as well, right? And then you have it in packaging, consumer products, industrial products. See, the biggest difference between us and the Chinese are they think big. We don't. If you want Apple to put up an operations over here for the scale of manufacturing, you automate it. If you want that quality, automate it. You want all the electronics and the semiconductor industry to come to India and give more job opportunities to people over here, you go for robotics. You cannot do without it. It's a part of the life. So how do we use it in plastics? First, put a check. If I want to invest in robotics, what should I do? Put a checklist. What is currently my cost of quality? What is the amount of rejections I'm getting? What is that I'm paying through my nose in terms of cost of poor quality? Look at that. It could be human driven, it could be process driven. Next, you look at the cycle time impact on your profitability. Look at it. Third on, what are the health hazards that you are looking at? There is something called as emotion, there is something called as intellect. Take a product of both of these two to make a decision, a fine balance. Then you look at the inspection methods. The data that is coming out of your system, they have to be automated. The data acquisition systems. So whether it is inward material or process, put a checklist together to see whether you need an automation. Then you look at the advantages that you are going to get as a result of this in terms of consistency, in terms of multitasking. This is exactly where it is important. We are not sequential tasking, we are multitasking here. That's where the productivity goes up. I will give you an example of a plumbing line valve manufacturer sitting out of India. The case study is there in Epson. Epson is known for what? Printers, right? Do you know they produce Cara robots? They are known for that. That manufacturer is producing 20,000 units per day using 6 robots right here in India. What are we talking? It's a case study in Epson website. Please go and look at it. An Indian plastics manufacturer is putting the plumbing line valves together. That's it. He says the difference was his father was holding person. Son went abroad for higher studies. He retained the same workforce. His turnover went 10 times. Now you tell me. Huh? He's using 6 Cara robots of the Epson type. So you look at the cost of quality, look at all the drivers, get your Pareto charts out, look at it, get the contributors, come back and say, okay, these are the areas which I need to fix. Take a step back and look at the global picture in your company. Next, you look at the process capability. See if that process capability, the sigma levels are maintainable. If it's not maintainable, what are the causal indicators? Whether it is humans or process or both. Then look at the recipe for automation. Whether it can eliminate that so that the process becomes consistent. Then you look at the centrality and spread. Data, folks. Look at your data. Don't say that I want to automate it just like that. No emotional decisions, only intellectual decisions. When you look at this, then you come back and say, okay, these are the things that I need to improve upon. Same operator, everything same. I give an input to a system. I put a process together. I take an output from the system. How do you expect the output to change if the input and the process are not going to be changed? That's where these kinds of automations come home to help us to get a deterministic output. In India, we require robots. You know why? They listen. We don't. Guys, Indians don't go by process. Japanese go by process. Chinese go by process. They will never question a process. The first thing that an Indian does is question everything. You put a process, there will be 100 questions for the process itself. Ellorum innattu mannar. Huh? You need a robot. Spawn out more. Coming back. If you want to automate it, if you want flexible automation, you look at robotics as an option. First, identify the CTQ challenges. Then determine the parameters that affect the CTQ. Cost, time, and quality. 3 denominators, right? That help you in your business. Third, perform a cost-benefit analysis rationally, both short-term as well as long-term. Then look at developing a project plan that includes risk assessment. Without risk assessment, most of these projects are doomed to failure. It's one of the things that people don't understand. Then you look at implementing programmable automation using robots as a part of the system, not the whole. I will give you a simple example. This is very passionate. You have this starter motors. You see it in all your vehicles, right? The starter motor has got 6 components. See the Japanese way, they see the Indian way. I want you to compare. 6 components, which includes the housing as well. The rotor, the starter, so many things. 6 components, 3 variants per component, 729 different product configurations. 3 to the power of 6. Produced in a single factory with 25 people, where the housing is taken as the fixture. This is Japan's answer for a starter motor. What did he do? He went and conquered the world. The name of the company? Denso. How many employees? 25. What is the market share? 70%. Worldwide, folks. Go to Padi. How many starter motors in one factory? How many employees? What is your market share? In India, forget the world. Are we listening? Is there a case made that is lost opportunity for this country? Please understand, it is lost opportunity for this country, not for party. You do it or somebody else will do it. Yes or no? So I am not putting a case together here for robotics. Economy is. Right? Now coming back, what is the options for in the plastic industry? If you look at it, worldwide, these are the areas in which, I'm sorry if the legend is not readable. The blue is palletizing, the magenta is loading and unloading, the orange is end-of-line packaging and palletizing. These are the three major areas in which robotics is being used in the plastic industry. Okay? Rest also follow as well. You can do it. So these are the areas. Now, in loading and unloading, it's a non-value added activity. It's injurious to the operator, especially if the payload is pretty high. And the fumes are coming. Health-wise, it's a hazard. You look at it in whichever way it is, this is what it is. 80,000 to 100,000 components is the mean time between failure for the manipulator. No bonus, no union negotiation. I love it when I say this. Hey, that's all required. That's required. I am an owner of a company. I love giving, so it's okay. Right? So you study which are the areas in which you are going to have problems. See, there are two aspects of it. One is cost savings. The other one is value addition. These are two ends of the spectrum. When you add value to the product, when you add value to the process, it is a self-sustaining business model. When you do cost cutting at the expense of others, you will be expended. That's a natural selection process. You like it, you don't like it. Why do you think Google is famous? Every one of you is doing searches, right? For no cost of it. Nothing to you. Are you paying anything at the entrance? So he is doing it as a service. He became popular. Today he is ruling you. He is listening to this conversation right now. AA is working overtime. Now, extraction from the injection mold. Cycle time control, clean room friendly, hard component control, shape control. You look at Motherson Sumi, when they took the component out of the unit for the door fascia for Ford, I can talk about it now that Ford has shut down its shop operations here. They came to the class and they showed the drawing. I said, this drawing is wrong. Sir, this is what Ford gives. Yes, Ford is wrong. Sir, 1 crore, sir. 1000 LH, 1000 RH. Phil Spencer was standing on the line with his tie on, rolling up his shelves, and he was looking at the fascia and he was rejecting LH, RH as the car was coming down the line. So I had to pay for the production stop as well. Why? Because of that hot control, hot component, shape control. No robotics, na? Manual, na? That there you will put a finger gripper, suction gripper, you will put it, nicely take it out, in hot condition, you will come and put it. What you see is what you get. You put this fella, you put this fella. On a nice day, he will do a good job. Huh? Able to relate it to your components? Kiska paisa hai? 1 crore. Whose money is it? Oops, I switched it. Next is insert placement in robotics. Insert placement is always a pain in the rump, especially when it comes to precision. Eliminate operator bias. Put it together. Get it done consistently. Nobody comes and tells you it's your problem. It's a design problem if there's a problem later on. Okay? So then the cost of poor quality comes down quite a bit. Visual inspection, again automation. High rate of detection. You put a guy there, he visually inspects and he gives you a report. Then customer comes and says, rejected. You say 10% rejection. Customer says 35% rejection. You scratch your head. Where is the problem? The guy is colorblind. These are statistics I am talking about. You painfully get to know that he was colorblind after the rejections which took place at customer place. See, I'll give a simple example. Already people are using robotics in a different way. They don't say it is robot. You know, rice sorting, it is done using visual inspection. 32 CCD cameras will be sitting, rice will be poured, color sorting is done right here in Coimbatore. They are a customer also of us. And then it is again put back, then again it's put back. It's 70% efficiency. But you put it 3 pass, 4 pass, you have sorted it out. Right? So there you are accepting that your efficiency of the process is only so much, but then you go through the process many times so that it's sorted out eventually. How many of you have seen bearing manufacturing, the balls manufacturing for the roller bearings? It's done using visual inspection right here in Bomasandra, SKF bearings. It's all robotized. No human beings. That's what I'm talking about here. See, the advantage of a Chinese guy or a Japanese guy over an Indian guy is the moment he looks at this remote control of the car unit, he will see how many million pieces you want. When do you want it? What is your price? He will go back and reverse calculate on the other side. He will talk only millions. Here we will be looking at, sir, 1,000 per month we'll give, sir. Yes or no? Scalability. If India has to grow, we have to shed the old baggage and move on to the dynamic conveyor. Again, in plastics, in packaging and in assembly of components together, you can use it extensively. It is done. All these are volume games. Now come back and look at what are the benefits that you get as a result of this. Higher productivity, worker safety, it's defect proof, value added services can be done by you. Watch this word, value added services. Flexible automation, AI, you put an automation together, you put the AI engine along with it, it starts going back to your previous data and it starts centralizing within the specification limit by itself. It's no longer your slave. Can it be done? It is already being done. The Apple phones are there. Testimony to that. Now is Samsung. Okay? The Oppos and the other ones will catch up. Don't worry. Get the point? Now, how do we go about doing it? This is where the problem is, starting trouble. Now you have given all the benefits. You have put all these things together. Now how are you going to go and buy it? Should I go and buy an HP, or should I go and buy an Epson, or should I go and buy a Fanuc, or should I go and buy a Comau? What is that I should do? Do it yourself. Have you heard of this? Has anyone heard of this? It's called as the robot operating system, which is available free of cost. You take the controllers, you take the microcontrollers, you put the software together, you are claiming that you are software powerhouse, right? Put a couple of engineers together, put mechanical, electrical, electromechanical engineers together, mechatronics, people are studying and coming out in. The population of number of engineers coming out of the state of Tamil Nadu is higher than the population of engineers in Germany. Coming out of Tamil Nadu is higher than the population of Germany, active professional engineers in Germany. So take 2 or 3 mechatronics engineers. I told you, right, in 1985 I did it with an 8085 processor for 20 hours a week in 8 months. Can't you do it? Today with a much better sophisticated technology available already. So you look at your systems, you develop the robot yourself. Put the operating system together. It's plug and play, folks. Did you get it? You didn't get this earlier, right? I thought you'll go and ask you to buy it from the shelf and put one robot inside. No. You know your business better than anybody else. You know where it needs to be automated. Develop it yourself using these tools and technologies, which is already available open source. First one is your microcontroller. Next one is your forward and inverse kinematics. Third one is navigation. Fourth one is CCTV, machine vision. Everything is available free of cost online. You have to integrate it, you have to put it together according to your business needs. That is exactly where your value addition comes in. Proprietary technology, you have IPRs in your processes, put it together. Take hold of consultants who will put this together. In say 8 months' time, you will have your robot up and running and it's programming. You know exactly what you are going to do down the line. Subsequently, looking at the larger picture, because I asked you to do it in your project planning earlier, short-term and long-term goals. Put it together, done. So Move It is the name of the app. Okay, it's open source. So you get it? Then you have the motion planning, you have the manipulation, you have the inverse kinematics, the control, the 3D perception, and the collision checking. Everything is available online, no cost. Take it, plug it, play it. Brain versus brawn. You want to do it the right way, the right-hand side way. When people get laid off, what happened with Nokia? 11,000 people got laid off right here in Chennai. You want that to happen? You go the other way. You want to automate it? You want to upskill the employees in the organization? Don't lay off people. Upskill the people and then get more productivity out of them. This is the way to go. The day is not far off when this is going to become a reality. It has already started. These benefits you will get if you automate it using flexible robots today. Thank you.